Welcome to 2.2, page 4. We start working on finding zeros of polynomials, and finding zeros of functions becomes a very important concept for us. In fact, that's pretty much what the rest of this chapter is about. So these ones are pretty straightforward. There's a couple little twists, but let's go ahead and take care of it. We're going to do these algebraically. I recommend, if you like, use your graphing calculator to check. But we're going to go ahead and do these algebraically. So we want to know when this function, when g of x hits 0, when this is equal to 0. And I can factor this or divide both sides by 5 and get x squared minus 2x minus 1 equals 0. Not the same function, but once we set it equal to 0, it's an equation. And at first thought that might factor, but check it closely. It can't be x minus 1 times x minus 1. It can't be x plus 1 times x minus 1. It's not going to factor. You can check through that. So we have to go to quadratic formula. So x equals the opposite of b, positive 2, plus or minus square root b squared, negative 2 squared 4, minus 4 times a 1 times c negative 1. I can't tell you how many times really good math students make that mistake and just ignore negatives. All over 2 times a, all over 2. That is 2 plus or minus. This becomes positive, positive, 4 plus 4, 8 on 2. That's 2 plus or minus square root of 8, that's 4 times 2, square root of 4, 2, so 2 square root of 2 on 2. Danger time here. I will see people cancel these 2's, but you have to cancel the whole top. You have to divide this term by 2 and this term by 2. So divide the top by 2 and I get 1 plus or minus square root of 2. Instead of 2 square root of 2's, we divide by 2 and we have 1 square root of 2, and the 2 in the denominator cancels. And those are our zeros. And again, feel free to go through with your calculator, graph it. You should see that we would have, here's 1. Square root of 2 is about 1.4. So 1 plus 1.4, a 0 here. 1 minus 1.4, a 0 over here. I believe our graph's going to look something like this. I know it's a positive parabola. So there you have it. Now after that one, truthfully, the work gets easier if we're decent at factoring. 40 they've factored for us. So if we set this equal to 0, either x cubed is 0 or x squared minus 9 has to be 0. So this would be x equals 0. This could be x plus 3, x minus 3 equals 0, or x equals negative 3, positive 3. Now, if you were going to graph this, which you don't have to, kind of an interesting graph. We have 3 zeros at 0. I would do this. This is a discussion coming up. 1, 2, 3 zeros. It's a triple. We have a 0 at 3. We have another 0 at negative 3. And here's how this graph would look. End model behavior, this function is y equals 1/4 x to the 5th dot dot dot. In other words, eventually it wants to rise to the right, fall to the left. So this is going to go up this way, down that way. This is more than what you have to do on this, but it's just a good problem. This is a first degree 0. Therefore, it's just a single 0 at negative 3 based on this factor. So it just passes through it like a line. This triple is the interesting one. Triples are third degree, and third degrees have that little swivel to them. This is going to come down, completely flatten out for a moment before going down. It's going to look like a third degree. And then eventually it's going to turn and come back up and pass through this one like a line. So just kind of an interesting discussion right there, a prelude to some other things that we're going to be talking about soon. I won't do that on the rest of these problems, and you don't have to do it on this assignment. Okay, number 42. If I was to set this function equal to 0, I would factor out a t. I get t to the fourth minus 6t squared plus 9 equals 0. And we have to be really conscious of, if we have a trinomial, we have to ask ourselves, is it quadratic? And you'd say, no, that's not quadratic because this needs to be t squared. However, and very important, if this exponent is double that exponent, and then there's no t's over here, it's quadratic, but quadratic on t squared. So maybe this thing factors into t squared something and t squared something. Are there factors of 9 that add up to be, I need two numbers that multiply to be positive 9 that add up to be negative 6? Well, minus 3 works. So this would be either t equals 0, t squared equals 3, or t squared equals 3. That would be t equals 0, t equals plus or minus square root of 3, plus or minus square root of 3. And while I said that I wasn't going to do it again, I can't resist. I'm going to do this again. You don't have to. There's a 0 at 0. There's two zeros at square root of 3. And there's two zeros at negative square root of 3, about 1.7. Those are doubles. This graph is positive t to the fifth. It wants to go up this way, down that way. Watch this. Here's a double 0 right here. Double zeros are from like x squareds or t squareds. They want to look like parabolas for that instant. So this graph's going to come up, touch, and go down. 0 is a single 0. It's just going to pass through. And positive square root of 3 is a double 0, so it's just going to touch and go up. And if you don't believe me on that, check that on your calculator. That's going to be the shape of your graph. Okay, if I set this equal to 0, I can factor out a 5. I get x to the fourth plus 3x squared plus 2 equals 0. Is this quadratic? It is quadratic on t squared. I have 4, 2, and no x's. So this could factor, doesn't necessarily, but it could factor into something like this if there are two numbers that multiply to be 2 that add up to be 3. And they do. So I get 5 times, well, I don't have to do that. Either 5 is 0, which is nonsense, or x squared is negative 2, or x squared is negative 1, but x squared can't be negative 2, x squared can't be negative 1, so there are no zeros. Let's think about this one for a second. This graph would start up 10, and then it wants to look like a positive parabola from there, and eventually it wants to go up in both directions. It's all above 0. Now, 46, you'll notice I changed it. I think that was an author error. 45 is actually factorable, and 46, the way they had it, is not. So I've modified 46. Please do so. And we're going to handle this one. If we have 4 terms, we might choose to try to factor by grouping. And factoring by grouping causes some people some problems just because you haven't practiced it much. Take a look. Out of these first 2 terms, I could factor out a 4x squared, and I would be left with x plus 1. Here's a little twist that I might do that maybe your previous algebra teachers didn't do. If I've got an x plus 1 here, in order for this to work, I have to get an x plus 1 here. I might not be able to, but if I can't match that x plus 1, this is futile. But I can get that in this case if I factor out a -6. And here's the one that's kind of a mystery. I remember when I was sitting in the seats that you guys were sitting in, this was a mystery to me, so I'm going to try to do my best. If I had 4x squared, let's say, times b, minus 6 times b, and I asked you to factor that, I think everyone here would know we could start by taking b out. And we get b times 4x squared minus 6. Well, that's kind of what we have here. 4x squared times this messy b minus 6 times this messy b. I'm going to take b out. So I get x plus 1 times 4x squared minus 6. Okay, just think of this as a whole package. If I distribute this to here, I get 4x squared times x plus 1. If I distribute it to here, I get minus 6 times x plus 1. So either x equals -1, or watch this, x squared equals, I'm going to add 6, divide 4, x squared equals 3/2, x equals plus or minus square root of 3 on square root of 2 when I take the plus or minus square root. Multiply square root of 2 on square root of 2, x equals square root of 6 on plain old 2 plus or minus. So there's my solutions. Actually 45 got some bigger numbers there, but it works out a little cleaner than that. And finally 48, y equals, factor out a y, or an x, excuse me. I get x times x to the 4th minus 5x squared plus 4. Set that equal to 0. And is this quadratic? It's not quadratic on x, but it is quadratic on x squared. X squared squared minus 5x squared plus 4 times no x squared. So x times, maybe it factors into x squared. Are there factors of positive 4, two numbers that multiply to be positive 4 that add up to be -5? Minus 4, minus 1. FOIL it, check it. X to the 4th minus x squared minus 4x squared plus 4. So that's x equals 0, x squared equals 4, x squared equals 1. So our zeros are x equals 0 plus or minus 2 plus or minus 1 when we take the plus or minus square root of. So there it is. There's page 4. 13-minute video. Definitely less time for you on this one. You don't have to do the graphing and the explanation. Let me know.